No, I was visiting actually for a time when you're
So we have our chair.
I will be calling him if we do not see him in a few minutes.
Cool. I'm just going to go in the back for a second.
Yeah, no, you have time. Cool. That's good. I'll call him. Oh, there he is. James, what up? James Landay, everyone.
Yeah.
Oh.
Yeah. Yeah.
And we have Mr. Perry Cook.
Hey, how are you? Thanks for making it.
It's Vanberg. Is Vanberg been restored? All right. Let me, in that case, show you.
What's up?
Hey everyone, and welcome. It's my great honor and pleasure to introduce Spencer Salazar, our PhD candidate and defendant today. My name is Go Wong, and while I've served as Spencer's advisor here in the PhD program in CCRMA for the past 6 years, Spencer and I have worked together since 2003, maybe 2002, sometime a long time ago. And we're both students in Perry Cook's Sound Lab in Princeton, and Perry Cook is here in electron form, and so he's on Skype from that computer. And I was doing my PhD then, and one day I got an email from undergrad named Spencer Salazar, who was like, hey, you got any research projects that we could work on together? I was like, hey, I'm working on this music programming language. I could definitely use a collaborator. And it turned out Spencer was a monster coder, was a monster designer, and probably much to his and to everyone's chagrin, he and I are still working on Chuck to this very day. In the meantime, between then and now, Spencer has accomplished a great many things, and I kind of made a short list here, just of some of the highlights. Chuck would not be anywhere. It would not be what it is today without Spencer, who has basically, he's the guardian of Chuck, but also the driving force behind Chuck's development for the past many years. He's also developed miniAudicle, which is the integrated development environment that the world uses. If you're chucking, you're using miniAudicle. One of the founding members of the Princeton Laptop Orchestra, co-directed Stanford Laptop Orchestra for many years, creating instruments, pieces, and actually helped to take the Laptop Orchestra to Beijing a few years back. One of the first developers at Smule, and so everything from Ocarina, Magic Piano, Leaf Trombone, World Stage, everything has spent part of Spencer's soul and blood and tears in there. And he also was had a cultural impact in CCRMA. I think he really made China Palace a thing. And also the Nut House, I believe, was also much popularized by Spencer. On that note, everyone is invited to a celebration after this at the Nut House. And I figured, depending on how this goes, either way, the Nut House would be good. Spencer will need a drink either way.
A celebration or a commiseration?
So everyone is welcome. He's now faculty at Cal Arts and teaching music and technology, and today he's going to talk about his dissertation. So before we hand things off to Spencer, thanks to all the committee, thanks to James Landy from Computer Science, to be the chair here, to Chris Chafe, also in the committee, and in the readers on this, Julia Smith, Harry Cook, and myself. And I should note that there's a direct academic lineage that is here. So that actually goes back 4 generations. So I advised Spencer. Perry was my advisor at Princeton. And Julius is Perry's advisor. So, and also to make things even weirder, Perry also advised Spencer undergrad at Princeton. So we'll let you figure that relationship out. Hand things off to Spencer.
Cool. Thanks, Scott, and thank you all for being here today. I see a lot of familiar faces that are nice to see here, and also some new faces. Anyways, my name is Spencer Salazar. I'm here to present my doctoral oral examination. Actually, real quick, this is actually kind of killing me. Just gonna turn Perry down a little bit. I'm here to present my doctoral oral examination titled Sketching Sounds, Gestural Interaction and Expressive Music Programming. Actually, there's still an echo coming from somebody. Cool. Way better. All right, awesome. Cool. So to get started, my research is focused a lot on mobile touch and creativity. Mobile touch technology has enabled a wealth of new creative experiences. Some of these include the Smil Ocarina. An application called Ocarina, which really reinvented how mobile technology can be used for musical expression. Another really inspiring use of mobile technology for creative purposes was Bjork's 2011 album, which had a tablet app form in which listeners could directly engage with music as it played. Another sort of related was Radiohead's Polyphony, which presented this expansive virtual world for listeners to engage with Radiohead's music. And mobile touch technology is really able to create these really exciting musical experiences using gestural control, things like direct manipulation, being able to touch and interact with things on the device itself. This enables this kind of tight feedback between the action that you're performing on the screen and the effect of that action. As well, the physicality of the device is incredibly interesting for creative and expressive purposes. The fact that a mobile phone is this thing that fits in your hand that you can move around with you presents a lot of interesting opportunities for creative expression. The motivation of my work that I'm going to be talking about today is that mobile technology has enabled this wealth of creative experiences, but these existing systems have avoided one of the most fundamental acts of computing itself, which is programming. I'm interested in the question, can we empower creative coding using mobile touch technology? I also ask, can a system for creative programming in some way actually work better on mobile touch? This is kind of, I feel like, a pretty important question. And I claim that mobile touch interaction, in fact, offers a natural medium for the programming of composition and design of sound and music. These technologies are characterized by intrinsic gestural control and interactive feedback, which are both fundamental processes of musical expression. I pull these ideas in the research I'm going to talk about today through 2 concepts involving text on the one hand and sketching is the other concept that I'm going to talk about today. So the roadmap for this presentation is to first discuss a text-based coding system that involves touch interaction. Next, to discuss a sketching-based system for musical and programming, to present an evaluation of these 2 systems, and then to discuss interpretations and conclusions. The contributions of my dissertation research are 2 drastically different systems for musical programming using mobile touch, one involving text and one involving sketching. As well, a contribution is the evaluation and comparison of these systems, and a conceptual framework for gestural interactive software using mobile touch. So a little bit of background. This research really lies at the intersection of 2 sort of generally distinct fields of music and computer music. On the one hand, we have interactive music programming. On the other hand, we have creative mobile touch computing. So to start with interactive music programming, this includes things like Chuck, which, as we all know, is very held very dearly here at CCRMA. Things like the Audicle, miniAudicle, languages like SuperCollider, Max and Pure Data, which are graphical programming languages, and programming languages like Fields, which are in fact combinations of both graphical elements and programmatic elements. Creative mobile and touch computing, applications like Ocarina, which I discussed before, are fairly interesting research in this area. As is the concept of the world stage, this idea where you can listen to people's musical performances happening around the world. The mobile phone orchestra was another sort of interesting application of these ideas, as is the React table, pretty much the canonical system for doing kind of large format touch interactions with music, as well as a wealth of applications that use OSC, various kind of creative, expressive activities using computing, touch OSC, control, Auraglyph, lemur, multitouch. These are all systems where essentially you kind of write a program on your desktop computer and you're somehow able to load it and interact with gestural touch interfaces. So to summarize really quickly the background section, if any of this is, you're interested in more of this, I'm happy to talk about some of these issues a little bit later, or feel free to look at this section of my dissertation. But to summarize really quickly, control and interactivity are incredibly important to musical programming. The systems that we described place control and interactivity foremost in their design. Gestural and creative possibilities of mobile and touch technology are also incredibly interesting. People are interested in combining these activities, being able to creatively program with mobile touch technologies. However, pretty much for the most part, the active programming itself has been avoided on these types of platforms. So when I sort of thought about this, I considered what's the first idea that we could try with this. And obviously, since I have a background in working with Chuck, I thought that we could try text coding and musical gesture on some sort of mobile touch platform. The result of this is miniAudicle for iPad, which is an iPad application that allows you to basically edit Chuck code. In addition to editing Chuck code, I was interested in finding out a way how you could leverage mobile touchscreen interaction in the process of working with Chuck code. Is there some way that you can kind of combine these two activities? So some of the principles guiding the development and design of this system is that, well, first and foremost, in the context of programming Chuck, you're not going to escape the fact that you have to deal with text. Chuck is fundamentally it's a textual programming language. But is there a way to make it easier somehow using various touchscreen-based techniques? As well, also integral to the process of coding in Chuck is live coding and performance. Chuck was originally positioned, among other things, as being a live coding language, a language you would get up on stage and type out different coding programs and run them interactively and performatively. So perhaps there's some way we can that aspect of Chuck programming into an iPad app. As well, the physicality of mobile is interesting in the context of programming. There's a lot of examples of various physical gestures being incorporated into musical production using Chuck. So how might we sort of bring that together into this framework? The result is an application that is split into basically two different modes, the editor mode and the player mode. So the editor mode allows you to edit Chuck code directly using a virtual keyboard with special keys for some of the standard Chuck operators and conventions. It includes your sort of like standard text editing features like autocompletion and syntax highlighting, as well as kind of plus, replace, minus, live coding controls. Player mode, on the other hand, the title of the slide is wrong, I apologize, is it allows you to load and fire off Chuck scripts that are arranged on screen in a more performative interface for managing running code. Basically what's going on here is these different code snippets are being loaded and then run and performed with interactively. So this was seen as a way to sort of somehow greater engage the touchscreen features of this device, integrate that with Chuck, while not actually having to type anything out. In addition to these two basic modes of miniAudicle for iPad, we created a feature where you could access the orientation and location sensing capabilities of the device within Chuck programs. This mirrors similar Chuck APIs such as the MIDI API, the Human Interface Device API, the Open Sound Control API. This basically would allow you to take sounds. Here we just have a simple example patch where we are mapping a sawtooth oscillator. We're controlling that basically by rotating the device in space. So anyone who's programmed with Chuck before should be more or less familiar with this sort of basic kind of structure of programming. It's an easy way just to kind of take existing ideas and incorporate orientation sensing and physicality into them. So to summarize, we've designed a system for mobile touch musical programming that is based on a metaphor of text coding. It provides an editor mode for text editing, as well as a player mode to have some sort of level of interactivity in live coding, as well as providing access to physical sensors of the device itself. Some thoughts I had after sort of working with this and trying to use it and trying to understand kind of what was going on with all of this. And perhaps these mirror thoughts that other people have right now, just seeing this. I was left with the lingering feeling that text was fundamentally an inappropriate medium for programming on a mobile touchscreen device. I just couldn't get this like feeling out of my head that this was just like I was doing something completely wrong. This is just not. This should not be allowed to exist. As well, it kind of adapts this existing metaphor of this string of text to the foreign setting of mobile touch, leading to this sort of fundamental mismatch between two things that just don't really intrinsically work together. So I wondered, what else could we try? And I guess one additional question to ask, to go back to kind of the initial positioning of this research, is this any better than programming on a desktop system? And to be honest, I couldn't really decide that it was. So the next...
Another question. So you edit the Chuck code, and then you can essentially move these snippets around.
Yeah.
Can I, while doing that, like hold down on a snippet and then bring up the code boom and change something?
Oh yeah, yeah, absolutely. So you could still kind of, there was still this degree where within the player mode you could edit them in that context as well. You could tweak a parameter, for instance, change a scale that you were using and be able to re-add that and reintegrate that into the mix. So there are definitely some blurred lines between the two modes. Cool. So kind of the next idea that we explored was this idea of sketching and musical gesture on mobile touchscreen devices. And this was sort of inspired by an initial insight. Starting with the presumption that text input is fundamental to many programming activities. This is sort of hard to disagree with in many ways. But typing on a touchscreen is really far from ideal. This is another thing that is sort of taken for granted. Handwritten text, on the other hand, is, maybe you could take away typing and add in handwritten text instead. In fact, using machine learning techniques that are now relatively commonplace, you could recognize handwritten forms of any type. You could recognize handwritten circles or squiggles or sine waves or filters or whatever. In fact, you could develop a whole system based around just sketching different forms, having these be detected by the system, and turning those into some sort of greater programmatic structure. So with that in mind, let's actually take a step back and look a little bit at the context of sketching and other manual processes in electronic music production. Sketching has sort of a long history in electronic music, almost as old as electronic music itself. There are a few themes that run through this context. One of them is this idea of raw input versus higher level structure. Are you basically just drawing some sort of curve that gets turned into, directly into the control for some sort of parameter? Or are you drawing something that gets recognized and turned into the sort of in-system structure, this thing that is recognized by the system? Another theme is this juxtaposition between sound design and composition. Are you literally just drawing a waveform that gets replayed kind of immediately and directly? Or are you exercising control over some sort of higher level compositional process using the sketching aspect as the input to that? In the early part of the 20th century, Mahalinaj, Hindemith, and Anthiel all independently experimented with writing record groups by hand. Unfortunately, these experiments were not successful at all. There's no evidence of successful experiments of that variety. People weren't able to really hand draw sound itself until optical film soundtracks became well known as a technology. For instance, let's see if this laser works. Up here we have various hand-drawn forms utilized by an instrument called the variophone. These would be basically rotated at specific frequencies to generate this sort of wide variety of different timbres and tones. This fellow down here, this is Norman McLaren, who is a Canadian animator, who basically hand drew the soundtracks for his films onto optical film itself. This was then fed directly into a film projector to replay the sounds he had drawn. The soundtrack for his Oscar-winning film Neighbors was actually produced using manual techniques of this sort. Those were all sort of analog processes. In the digital realm, Ivan Sutherland's Sketchpad is really just sort of the ultimate example of using sketch input as basically a way of computing. Max Matthews, in fact, used the Graphic 1 computer to develop a graphical programming language, or a graphical composition language, rather, in which we see over here basically handwritten forms like the one we see being drawn there were used to control synthesis that was designed in Music 4. Yanis Xenakis designed a system called the UPIC, which combined sound design and composition together. You would basically draw waveforms that would then be composed using additional drawn figures that would map various parameters of those waveforms over time. So there's a lot of interest in the digital world of working with these things, working with hand-drawn sketching processes in music. Commercial graphics tablets, starting in really, I suppose, the 90s, became fairly popular as well for various creative processes. And James Landis's Silk was basically a system where you could draw various user interfaces and have a window be recognized as a window and a button be recognized as a button, and have the system be turned into that sort of thing. So you could actually draw an interface and then be able to immediately interact with it directly. In the realm of musical expression, Matt Wright, David Wessel, Mark Trail, Doug Van Noort, members of the Princeton Laptop Orchestra, and many others, really, that I surely haven't talked about here, all had various research and compositions that incorporate graphical tablets. These sort of range from very direct mappings, where as you move your pen around, it directly controls some sort of musical parameter or some sort of synthesis process, to sort of more high-level mappings where you would instead control this kind of generative algorithmic process that evolves over time based on your input. Taking a step even further back, sketching in general, I believe, is really integral to the entire creative, to just an entire wealth of creative processes, including prototyping and development. William Buxton describes sketching as the archetypal activity of design. Dover Plank describes sketching as the experience of any craftsman in direct engagement with his materials, imagining, shaping, and seeing all at the same time. This is kind of a powerful notion, this idea that you have this idea in your head, and then you're able to quickly work it out by sketching and see that, oh, there's something wrong here, and you can change it, and you can erase something, add something different, tweak things. It's this sort of dynamic conversation between the idea that you have and this kind of sketched out physical manifestation of it. I think it's an incredibly powerful concept for designing perhaps some sort of computer music system. Which leads us to Auraglyph, which is a sketch-based system for programming, composing, and performing musical systems. We developed Auraglyph initially as an iPad application. according to a few kind of basic underlying principles. The first is that what you start with in Auraglyph is this freely scrollable infinite canvas. With that kind of in place, you can use stylus input to create different programming structures. And the way that happens is that raw pen strokes are basically reified into these sort of programmable objects that you can then build into more complicated systems. You build them into more complicated systems by being able to freely connect them with each other. You draw connections between them, and that creates basically this network of nodes that form a program. Continuing, touch input can then be used to parameterize these objects. If you draw an oscillator, now you can change its frequency, or change its gain, or change the cutoff of an envelope. In some cases, stylus input might be better for parameterizing these objects. For instance, if you can imagine being able to directly draw the waveform that an oscillator uses, or being able to draw a filter frequency response. These are things that would be more suited for stylus input. Auraglyph also allows you to just simply draw freehand drawings. So, if you want to draw a giraffe next to your sine wave oscillator, you can do that. It really allows this ability to kind of creatively work with this idea of sketching, whether that's something just purely you want to draw something, or if you want to maybe annotate something and say, this is the part that does this certain part of this program. And then the last kind of principle that has been kind of an important part of Auraglyph is real-time feedback and visualization. Auraglyph constantly gives the programmer an idea of what they've just done and how all the different parts of the system are interacting with each other. All these different parts are sort of passively represented to the user. Nothing is shouting at you saying that your oscillator is too loud or your filter is too modal. Instead, it just sort of passively telling you, hey, this is kind of what's going on right now. So with that kind of in mind, rather than talking about the design, I think I would actually like to talk and show a bit of the design of Auraglyph. So I'm just going to switch to the camera here, which should be okay. So here we start with basically this freely scrollable infinite canvas. And we have a speaker icon in the middle of it, which represents our audio output. To get started, we draw a circle, which represents an audio waveform. Then we choose basically which kind of, or rather, not necessarily just an audio waveform, but any sort of audio processor or unit generator. So I'm just going to choose a simple sine wave. To connect it, I just draw a line from from this guy to that guy, and we should be hearing some sound. So that's just a simple sine wave. And then we can do it in stereo, of course. And to parameterize this, we can then pop open an editor window and be able to change the frequency. Cool, so that's just getting started. We can draw an additional oscillator, and why don't we go ahead and modulate these? People like modulating things around here, like here. So it's fairly easy to get started with these kinds of things. I think it'd be interesting to maybe have an envelope on this. These sort of static sounds can get kind of boring at times, right? So let's go ahead and add an envelope to this, which we can do with this ADSR here. If we just connect them through each other, now we don't hear any sound because we need to trigger the ADSR with some kind of pulse. So for this, I'm just going to use a basic square wave, turned down to a low frequency. If I turn the frequency down to, let's say, I could in fact even just write in a value here, assuming the recognition will accept it. This is going to pulse it every second. And I could change the width to make it shorter, or change the frequency. we can continue to sort of develop this by maybe adding a processing effect. Oops, I didn't mean to do that. We can add some delay, for instance. If we find these waveforms to still be somewhat boring, we can go ahead and draw our own. And here, let's pop this guy in. Oops, sorry, that's actually noise. The drawn waveform is this one, which I'll connect here. So it starts out as just a sine wave, but I can make kind of creative modifications to this, however I choose. In fact, of course, I can even modulate this with another, oops, I keep picking out noise for some reason. I can modulate this with another hand waveform by adjusting the gain. Cool. So there's one aspect of this that is fairly, I haven't really talked about yet, which is being able to control all these sounds. There's a separate class of nodes that you can draw that are control reprocessors. So if we draw a square, we can get access to these. So for instance, there's a sequencer here. There's this kind of array object here. There's a number of other things you can do. I'm actually going to use the orientation sensor, which is what this corresponds to. It's going to basically measure the orientation of this thing in space. And then I'm going to draw a multiplier so that I can make its effect more pronounced. So let's just take the x-axis here, multiply that, and feed that into the frequency. So right now this thing is pretty low, but if I multiply it by a big number, like 1,000, and then actually pick up the device, and let me actually increase the frequency. Pretty quickly create these kind of gestural orientation-based interfaces. That's just kind of a basic rundown of how all the various pieces of Auraglyph operate with each other. So let's switch back to these slides here. Just move this one. Okay, so I want to draw specific attention to the aspect of visual feedback in Auraglyph, because this is actually a part that is incredibly important to me. Basically, all the different parts of an Auraglyph program display how they're communicating with every other part. So you can see these sort of pings from each control node as it is sending new data to all these audio nodes at the bottom here. As well, audio waveforms are represented on connections between different audio pieces. These audio waveforms aren't the result of any aggregate process. It's literally what audio is being passed from one node to another. So you can see pretty instantly what each part of this is doing. It has this very kind of functional aspect of seeing how your program is working at a very kind of discrete level. But as well, it creates this kind of living, breathing system that is, I find to be interesting from an aesthetic perspective as well. I think it's fascinating to sort of watch this thing kind of organically expand and contract and go through various phases of existence, all kind of out of sync with each other. And this kind of ties into the overall aesthetic of the application. It kind of has a very distinctive aesthetic, and it doesn't necessarily have to be that way, but that's just the way all these things sort of fit together. In terms of the technical implementation of Auraglyph, it uses a handwriting recognition engine based on a library called LippyTK. It's an open source library for doing various types of stroke recognition. The specific algorithm that's being used in Auraglyph is strokes are being resampled and then run through a nearest native classifier, to decide which particular figure a given stroke is. But nothing is really dependent on this specific handwriting engine. I've started to investigate using alternatives for this particular engine. As well, the visual engine is based on OpenGL. It's not tied to any specific platform. The audio engine is C++ based. All of this is sort of written in a way that's very abstract from the underlying hardware. So Android tablets, Microsoft Surface, any of these sort of competing products, similar products that have the same general set of features would be possible to use as a platform for Auraglyph. So to summarize, basically we've designed an additional system that's quite a bit different from the first one for mobile touch programming of music. It employs a sketching metaphor in which raw pen strokes are reified into these programming structures. And then these structures may be flexibly interconnected using additional pen strokes. As well, visual feedback of the system state is sort of provided to the programmer throughout. And returning to this question, is this any better than a comparable desktop system? And kind of on first glance, I feel like it's definitely a step in the right direction. But to answer this question a little bit better, we've proceeded along evaluating Auraglyph and miniAudicle for iPad in a number of different ways. Our approach was quantitative evaluation, basically assessing different metrics based on scoring, essentially, and also a qualitative evaluation based on user feedback, users telling us whether they liked it or not, or why. And of course, for me, really the most important evaluation is actually making music with it. None of these other metrics really matter that much if you can't actually make any good, or if you can't make music with it that is interesting in some way to someone. So to start with, we evaluated miniAudicle for iPad with music technology students from California Institute of the Arts, where I teach. These students were familiar with Chuck. They were familiar with making music using technology in a number of different ways. They were asked to use miniAudicle for iPad for approximately 1 week. And in that span of time, develop a basic instrument or musical statement or other creative work. After doing so, they would demonstrate the results to me, show me what they did, and then fill out a survey anonymously where we assessed a quantitative metric called the Creative Support Index with a couple of tweaks, as well as soliciting qualitative feedback, basically asking them what they liked or didn't like about the app. We also collected automated analytics, basically determining what buttons they pressed or what sort of screens they were looking at, what kind of activities, automatically determining what kind of activities they were engaged in. So an example of something that was made during this study is shown here. Oh. Next time. And some of the feedback we received from participants in this study were that they appreciated the expressivity and mobility using the built-in sensors of the device. They enjoyed the laid-back experience of not typing on a keyboard. And one person stated that they ended up enjoying it much more than they anticipated. So it turned out to not be that bad necessarily. In terms of the negative feedback we received, one participant quite plainly stated that they just didn't like coding on the iPad. They said it was really cumbersome to type all the code without a regular keyboard. And they said that developing any project that might be larger in scale, bigger than a single program or bigger than a single, a single class, would be near impossible to manage. So, it's possibly interesting for creating these sort of one-off toy experiences, but maybe not necessarily a way to engage in a deeper way. In terms of the quantitative metric that we analyzed in this study, it actually scored fairly well along these kind of axes. These are the kind of different categories that we assessed in the Creative Support Index with the tweaks that we made. These, I'm just going to say like straight up, these values are way too high. I think they were trying to not hurt my feelings or something. I mean, these are students that I know and interact with fairly regularly. So for it to score this highly out of 5 points on not just any of these but all of these seems unreasonable to me. So part of this I don't really buy, but nonetheless People didn't entirely hate it, so I guess that's positive. We then started to look at Auraglyph in the context of a user study. We distributed Auraglyph to students of the CalArts course Composing for Robots. We followed the previous study protocol, give it to them for a week, see what they come up with, fill out a survey anonymously. After that, we asked them to develop concert works over a span of about a month, which would be presented at a concert at the end of the semester. One of the pieces that they developed was pretty interesting to me. It was called Hedonism Bot. And in this piece, performers used Auraglyph to process and control an acoustic feedback loop between the iPad and the speaker. As they rotated and moved the tablets around the speaker, various parameters of the sound processing were being modulated by the device's orientation sensors. So it was this sort of cohesive interaction of physical and digital processes being really combined in a really interesting way into this performance. The feedback we received from students in the survey, they appreciated that when it worked, it was fun to push it up against the limitations of the software. It was very easy to learn with an intuitive interface. It felt like playing, facilitated exploration. Less positively, people found that it was somewhat more difficult to be expressive, more conducive to producing noise. Ignoring crashes, etc., the drawing was always frustrating. And that with the ability to save multiple projects, undo, etc., it would be a much more satisfying approximation of the modular synth experience. So I'll point out that these last two items are really, they really speak more to kind of the absence of the basic software engineering features. These don't really speak to any kind of deficiency in the design or the concept of Auraglyph. I don't think they really attest to any of that. It's really just, I didn't code it very well, so it crashed all the time. It's pretty much as simple as that. So there's a couple of things, I don't necessarily see this as being an invalidation of the idea behind it, rather that this specific implementation was deficient in a number of very apparent ways. As well, this particular study, Auraglyph, just completely bombs compared to miniAudicle for iPad. People really did not like it for a number of reasons. And this was actually incredibly surprising to me at the time. I really did not expect this at all. I assumed that people would use the software and understand that it's a cool idea and be happy with that. But in fact, they really like miniAudicle for iPad a lot better. Sort of in parallel with all of this, I conducted what I call a personal evaluation of Auraglyph, which was really part of this iterative development loop. Really any kind of any sort of creative software development process, really, in my experience at least, involves this kind of constant feedback between designing and implementing something and then using it and deciding if it's a good idea or not, and seeing kind of what sort of creative ideas what you just designed and implemented can actually facilitate. It's this constant loop of basically development and then use or assessment. So amidst all of that, I was asked in fall of 2016 to develop a set for a solo live show, for which I decided to do Auraglyph about 2 weeks before I was actually supposed to play at that show. And I want to go ahead and point out that it was not clear at all if it would actually be possible to develop a set of music using Auraglyph at the time. I pretty much just went for it. There was a bit of danger involved, but it turned out all right. I developed two pieces as a result of this experience. One of them is called Drone, one of them is called Pulse. And actually, I'd like to go ahead and share part of one of these pieces to you right now. not sure how much of that is really apparent from watching me do it up here, but to me, like, it actually requires a pretty significant degree of performative effort. This is actually work. It was actually work to perform with this thing. It was scary in a way. I would get up and not know if I was going to screw it up somehow. And at the same time, it's kind of an exciting idea. This idea that you have this digital musical instrument that you can actually make mistakes with and actually have to practice with to become good at it. So it really took effort to kind of enact the various musical progressions and the musical ideas that I wanted to achieve. As well, on the other side of that coin is that failure would mean that a particular musical idea wouldn't work out the way I wanted it to, or perhaps in some cases the whole thing would crash, the whole thing would just come tumbling down. So there were some kind of very real ramifications to performing with this. So circling back, based on the user feedback we received in the user studies, we decided to fix some critical bugs and address some of these features in Auraglyph. We fixed a bunch of crashes. We added the ability to save and load programs. We added multitouch interaction, and we retrained the handwriting recognition. After that, we held an additional user study for Auraglyph based on a 2-week intensive workshop at CalArts. We used the previous evaluation protocol of getting people to fill out a survey after 1 week of using the app, and then held demonstrations and a mini concert at the end of this workshop. This to me was actually an incredibly interesting and rewarding experience, seeing people use Auraglyph in this workshop. I would leave for like a minute and then come back, and students would just sort of be naturally grooving and jamming with Auraglyph, and just really, it seemed like in many cases they were transfixed by using it. Collectively producing this spatial landscape in the room of all these new sounds and diverse musical ideas. It was incredibly exciting. Some students told me that they stayed up late until the early morning composing with Auraglyph. I mean, I didn't ask them to, and in fact, the parameters of this workshop were very casual. It was kind of just show up and do what you wanted. And yet some people just were so into it that they went way beyond what I asked them to do. The musical results as well were pretty exciting to me. So let's go ahead and listen to some of those. Those are some of the examples of pieces that people made in the workshop. Some of the feedback we received, Auraglyph promotes destructive creativity. You throw us into more us. There's this mindset that you're not going to create this harmless thing. People enjoy that they just make music. They just want to keep going. It sounds good. They're not thinking about EQing or any annoying DAW shit. One student, upon finishing a piece, showed it to me and was like, I want to hang this up on the wall. You know, they felt like they had created this work of art that they wanted to preserve. So that was all very exciting. On the negative side of things, people mentioned that they could only really make a single collection of sounds. They said that it lacked conventional melodic phrases. They said that syncing is possible, syncing between multiple tablets or syncing between multiple performers is possible, but challenging. And you know, I think these kinds of impressions are to be expected, especially when people sort of first encounter Auraglyph. I would argue that these kinds of issues are less of a concern as you become familiar with kind of how Auraglyph works and the kinds of things that it allows you to do. In terms of our quantitative analysis of Auraglyph, it definitely worked out better than the first user study of Auraglyph, which was exciting. And it also, in most respects, worked out better than miniAudicle for iPad. So something changed that somehow made it work out better in this particular regard. So based on these user studies, I feel comfortable drawing a number of interpretations. One is that software reliability is crucial for computational expressivity. Just having basic document and state management can really enhance creativity as well, being able to save and load documents, being able to undo and copy and paste. I mean, these are like really basic things. They're not groundbreaking ideas in HCI research or anything, but nonetheless, they're important to enabling creative freedom. They allow people to explore different ideas creatively, and if they go through with some particular idea, they can back out. If they decided that something was a mistake, they can undo it and go back to whatever they had before. Going a little bit deeper in terms of interpretations of these studies, I think it shows pretty clearly that the physicality of the device itself is interesting. A lot of the pieces and things that people made in these studies really engage the physicality of the device itself. As well, ultimately, design and interaction is key. Users were able to engage with design. It drew them in. It made them want to use the software more. It made them want to create things, which is important. It wasn't like this chore that they had to do. Visualizing system state is also an important aspect of this, I feel. Being able to show all the different parts and being able to understand how they're all interacting with each other. And also just kind of giving you something to look at when you're bored or whatever. As well, the overall interaction and metaphor of sketching, I feel like, is to some degree validated by these studies. People felt like that was an approachable way to develop music. So in summary, we've done a multi-part evaluation of these systems for musical creativity and performance. Just a final discussion and conclusion. So we've developed these two systems for software and mobile touchscreen-based devices. Based on this research and some of the related work discussed earlier, I've developed a framework for analyzing the design of software that uses mobile touch interaction. This framework has 5 parts, visualized by this handy diagram over here. They are touch interaction, which can then enable direct manipulation, dynamic graphics, physicality, network, and identity. Touch interaction really allows people to be gestural and expressive with software. It also supports direct interaction. It allows people to directly kind of manipulate virtual objects on the screen. This complements the physical aspect of software and of this entire experience by kind of sustaining this illusion that people are actually interacting with some sort of real thing, or at least like semi-real or virtual real. Dynamic graphics also work to this effect. That's the second kind of item in this framework. And not just graphics, but also animation. Animation can kind of indicate to people really like what's going on in the system and give it this sort of life that is important for people being able to like not get pulled out of the experience. It helps if these graphics are guided by the principles of the physical system. Having things kind of naturally decay or naturally grow, not having things just disappear off screen. And to that effect, natural motion is much more important than a realistic appearance. Nothing that we see here really looks especially realistic in terms of appearance, but to me, the natural motion of everything kind of does give it this life. Physicality is the third item in this framework. This includes the physical features of the device itself, its size, its shape, its weight, how it feels in your hands, the things you can do with it. Can you put it in your pocket? Can you carry it on the train? Can you take it into bed with you? Things like that are important when considering these types of systems. As well, the relationship of the device to the outside world as communicated by various sensors, right? So being able to detect the orientation of the device, to tell where it is in space, to tell where it is geographically. Moving on, the fourth item is network. Mobile devices are inherently tied to the network. A mobile phone would not be much of a phone if it couldn't actually access a network in some way. It's kind of the whole point. So these provide compelling advantages for software to use for creative ends. In some ways, you can view the network as this virtual layer on top of our physical reality. And the last item in this framework is identity, which is a little bit more ephemeral than the other ideas I talked about. But in some ways, I think you can view mobile devices as really an extension of yourself in ways that a computer, a desktop computer, is not. Users of mobile technology have an incredibly unique relationship to that technology because basically it's a communication device. It's how they communicate with their friends, with their parents, with their loved ones. You have to sort of factor this into how people, like that doesn't go away when people start making music with it. They still see it as this device that they identify with. So to summarize, the contributions of this dissertation are two drastically different designs of systems for musical programming using mobile touch. One of these systems uses text. One of these systems incorporates sketching. We've also evaluated and compared these systems through a number of user studies and personal evaluation. And we've developed a conceptual framework for gestural interactive software using mobile touch. The two primary publications related to this research relate to Auraglyph and miniAudicle for iPad. These have been also supported and sort of preceded by a number of other publications listed here. Some of the concerts and musical works that were developed in this process are noted here. Some of these are actually upcoming. A number of the works that people developed in the workshops and courses that were held for user studies are now being developed into sort of full-fledged concert works. I think that means it's time. If any of this is interesting to you, I'd be happy to discuss more. Please check out the website. And real quick before I finish, I just want to say this is not been really the work of one person. I've had tons of help in various ways. I really want to thank my parents. Janet Gray and Mary Salazar, who are here now. I want to thank my brothers, Tyler and Jesse, my sister Dominique, and my nephew Ro. My friends, some of my friends who have been amazing all this time, Tesla Munson, Mark Sequoia, Jack Canbar. I want to thank my committee for really being here and providing some really cool feedback. Go Wong, Perry Cook, Julia Smith, Chris Chafe, and CCRMA is just like such an amazing community. And it's really been, it's been an honor being here this whole time. So I want to thank all of the faculty and staff that I've interacted with and learned from over the years. Jonathan Abel, Jonathan Berger, Dave Berners, John Chowning, Takako, Yark, Sasha, Fernando, Carr, Nettie, Matt Wright, and all of my amazing CCRMA friends. Like really, like the community of this place is just so awesome. Rob, Chrissy, Roman, John Ganzo, Hongchen, too many people to name really. I want to thank Dave Kerr actually for operating the live stream as he does for so many of these CCRMA events. It's really an amazing service. And I also want to thank all the students and other individuals who participated in the user studies and provided incredibly valuable feedback in the development of this research. So with that in mind, I'd be happy to field any questions or have any further discussions on what I talked about. Thanks. Any questions?
first of all, great work. I mean,
Thank you.
we've talked about it on phone and stuff, but really impressive to see. One of the major criticisms of visual programming languages is always about how they scale. They don't scale like textual languages in some ways. So I'm curious, in your own composing as well as in these kind of studies, what's the largest composition that was used and or created? And did you run into the scaling problems, or did somehow the design, even with the infinite sheet, kind of constrain you?
Yeah, no, I think I would absolutely admit, just straight up, that there are definitely scale issues in the implementation of Auraglyph as it stands right now. One of the major components of Auraglyph that is kind of still under development and wasn't able to be completed in time was being able to kind of wrap things into modular components that can then be reused in a number of ways. I have a number of criticisms for the way existing graphical programming systems handle modularization of code and the way that people are able to interact with those. Without getting too much into that, I do have a few ideas that I think could be further prototyped and explored in terms of how you might be able to address scale issues, even being able to modularize code.
Yeah. I don't understand music enough to understand it, but it, like, from on the surface to me, like semantic zooming seems like a really interesting fit for this, in that you can zoom out and see things at a different level and deal with things at different levels. Kind of the work that Jim Holland seems like it could be great for a language like this, but I don't know.
Cool. Yeah. No, I think what I've discovered is that a lot of these ideas just haven't really been explored in the musical space, and being able to do that further would absolutely benefit this research.
Just make sure.
Okay. Yeah.
Is there any sort of way to begin a sketch on Auraglyph and then use that same file in some other, let's say, desktop text base, but something where you could scale it up then or just add it to an existing project as a, oh, I like the sound, I want to use it now in whatever that thing is.
Yeah, so just for the online viewers, the question is there any way to sort of take something that you developed in Auraglyph and be able to kind of wrap it and compartmentalize it in a way that it can be used in other contexts?
Well, either that or access the source code, let's say. If it's,
okay, or access the source code, yeah. I think that's an idea that I've started to play around with. I like this idea of being able to sort of export Auraglyph code as like actual code. I've mostly worked with that in a context of being able to sort of, one of the ideas that I've started to prototype is being able to create an Auraglyph program and then have that dynamically update the actual audio processing that's happening on like a host computer, like within like a DAW or something like that, within like a plugin environment. So that's kind of one aspect. I think exporting to code is a little bit more, it would definitely be a little bit more involved, just because the system as it's designed right now is not, it's basically just this sort of graph structure that doesn't really lend itself to code per se, without having a full-fledged Auraglyph interpreter, which sounds kind of crazy. But ultimately, like, there's this idea, I think, that the programs that you make can be, in some sense, I think, abstracted from their visual representation, but part of me also feels like that's missing the point. Like, if you can design something in Auraglyph, it's not so much about, at least how I sort of feel like after working with people with it and working on it myself, like, I feel like using it in this context is almost the whole point, So like being able to export doesn't give you that much if you lose all of these other capabilities, like by putting it on a regular computer, putting it on a watch or something. Yeah.
I've got a question from the chat room. So Diana says, Spencer, what's the next step where you see this research going from what you've learned from miniAudicle through to Auraglyph?
Yeah, well, I think so what's the next step? I think James's question is actually incredibly apropos in that regard. I think really the next step is figuring out how to really kind of build the parts that are missing when you think of like what are you doing in your programming. So one of those things is being able to scale to different levels, I think. One of those things is being able to encode different types of procedures, different types of algorithms. That's something that is difficult, or it's difficult for me to see how you might do that in Auraglyph right now, how you might be able to make some sort of algorithmic process based on something that we might do in the traditional procedural or functional programming. So kind of grappling with those issues, or deciding that for whatever reason they're not important, I think is kind of the next step. Good question. In the back, yeah.
Oh, okay. Thanks. So this is a little outside my field, but bear with me. You only, in terms of Auraglyph, you mentioned network right at the end briefly, and I was just wondering if you had any plans to incorporate like this worldwide network like you had with Ocarina, where people could interact on that sort of global scale.
Mm-hmm. Yeah, that's a great question. I think there's sort of a number of different ideas that have actually been considered and have been kind of toyed around with and sketched out to some degree. One of them is actually being able to perform with people locally, being able to kind of pair up with people, and we can all sit down here with our tablets and jam in a way where one of the very first ways that networking was used for music was just sending control data to other performers like that were there with you. Being able to just set something like that up where it just kind of works in sort of seamless fashion. You can kind of send whatever notes you want to the guy next to the person next to you, or whatever, things like that. From the global perspective, I think it gets a little bit more challenging, just because there are issues of latency. Like information can only travel at a certain speed. It's bounded by very real physical constraints. So, in some of the historical research that I mentioned, there were a number of techniques that were used to sort of sidestep that. And basically, effectively, a lot of these systems for doing network music were not real time at all. You weren't actually ever playing with anyone at the same time. But it really comes down to how do you address that issue when you're doing any sort of global musical experience. Good question.
Yeah, so I want to ask about the connection between the programming through gestures like drawing and the gestures that people use when they use the instrument to perform.
Mm-hmm.
There's a real kinship between what we do with a device that we hold in our hands when we perform with it and drawing. I mean, it's like drawing, right? We're moving our hand around in this 3D space. And I wondered if you made that connection, or if that came up, or you thought about that kind of mapping of that kind of drawing and incorporating that into the programming. Something like Rebecca does, I suppose, with mapping naturally between gestures and scaling and ranges and sounds that you are designing with your algorithms.
Yeah, absolutely. Actually, I remember a great point that Chris mentioned is when I first proposed this idea was that something along those lines where actually the gesture of this drawing itself could be in a very direct sense turned into sort of the control of the system. And I think to some degree that hasn't been explored too much, but in the current form of this research. But I think that there is sort of a lot to be said with that. Before really, what I have up here is an iPad Pro model, which works with basically like a dedicated pen that can tell. The real key thing with this pen is that it can actually tell the system that, hey, I'm a pen, not a finger. Every other stylus that works with tablets, basically, or works with Apple tablets, just looks like a finger. There's no way to differentiate between them. Whereas with something like this, it's more like kind of like a laptop digitizer type pen, where you can actually get all this information about it. But one of the things I had considered before I realized it was just way too out of scope was actually developing like a custom pen that would communicate through the data protocol into like the audio input and be able to give you all these different kind of like things about how hard you're holding it, Or like, are you holding upside down or right side up? Maybe you could have like an erase gesture or something like that. And just having kind of really like turning that into like this sort of very physical thing by itself. I think, more generally, I think there's kind of a tension between how you perform with something and how you compose with something. In many live coding contexts, these are the same, but I think to me that sort of seems a bit silly because they're two fairly different activities, kind of at a mental level and at a physical level. So, yeah, I think it definitely kind of merits further exploration and kind of understanding how you might approach that. Yeah, Chris.
I think we saw a snippet of the one called Quartet. Is that true? There were 4 people, and they were all nodding their heads together.
Yeah.
So, how did they get kind of sort of rhythm sense? Was it something they could actually enforce, or?
I don't think there was necessarily any. Obviously, as I mentioned earlier, there was no real like direct syncing between.
But they were doing it with their heads. That's what.
Yeah. I think to some degree they were sort of. I imagine I would actually have to ask. I mean, it's a great question that I should probably ask them directly because. I don't know. I can only speculate right now.
They found a way.
What's that?
They found a way, or something.
Yeah. I mean, what I think is interesting with these types of systems is that sometimes when you explicitly don't have a feature, people will sort of come up with these kind of more humanistic ways of compensating for that. If you don't include if you don't include a big button that says synchronize with everyone else, people will figure out a way if that's something that they actually desire. I mean, ultimately, that's how we did it in the old days, right? So, I think kind of having it be this, it almost suggests maybe it's not worth considering that as a feature in this to be able to have like a direct mechanistic.
It's kind of nice.
Be kind of nice. All right. Yeah. No, for sure. Yeah, I think it's interesting to kind of to see those two approaches for sure. And I think ultimately that is kind of a big next step is allowing people to kind of collaborate.
So just a side on that, I showed more, but there's a sort of parallel dissertation happening right now at Princeton. Reed Oda, it's another student of Rebecca.
I think I've seen that.
Yeah, and it's called Global Metronome. It uses GPS, and it can be that quartet, or it could be transcontinental.
Interesting.
Very practical.
Yeah, no, I mean, I think fundamentally it would be nice to just have this sort of abstract way where it doesn't really matter if you're playing with someone right next to you or someone that is, in a completely different country. But yeah, I think the ideas they all sort of exist. They just need to sort of be brought into this world. So, cool.
So I think actually I'm going to defer to our chair here. If you feel okay, should we
Move on.
move on?
Sure.
Yes. Okay. So I think maybe this is how. Let's take. I think the committee and Spencer. Let's take a 5-minute break, and then we'll convene for the closed doors part of this. And then outside is a lovely reception that Spencer's family have set up. So please go and enjoy that, and Spencer hopefully will emerge alive after the closed door session. And yes, we'll go from there.
Yeah, exactly. Very hard to get say something about oh, that's good. Thank you. Always talking about running up on the wrong side. I don't know what I did. I think you're doing this.
See you, John. Yeah. See you, John. Yeah, thanks.
Oh, really?
No, we went, I think it was Korea.
Okay. So more reason.
Not house. We'll drink and carry.
There it is.
Does anyone want to wave at the chat room? There's Diana. Everyone's online there. So there's Diana. There's Julia. Do you want to do a quick camera thing? Yeah. Okay. There we are. There's me. I guess. I don't know. Okay. We've got Kurt and we have Diana.
Oh, no, it's all good.
Okay,
Let's
that's
take
it.
the 3 o'clock. We're collecting